If you can't hold it, you can't cut it. This video is about the tips and tricks that you need to be successful to hold your parts securely, regardless of the type of CNC router you have or the vacuum pump that you have. These are the things that you need to do to be successful. I've invited Greg Smoka from the CNC tooling shop to help me talk about the different products that we're going to need to be successful with these suggestions. The first suggestion I have for you is your focus needs more focus. Anytime that you can take the power of your vacuum and condense it into your working area, you're going to be successful. In this case today, we're going to do a little bit of work to set up for this vacuum jig that we'll talk about a little bit. And in order to do that, I need to zone it with some gasket tape. Tell me a little bit more about this product.
First off, gasket tape is a consumable. This is not weather stripping that you can get from Home Depot. This is a closed form gasket, and it's very important to replace and maintain this material. Here at CNC Tooling Shop, we have all different sizes, whether it's a rectangle, square, or even a circular shape.
So you can see how the vacuum would come up through these ports, through this grid, and then be blocked by the gasket tape. Now, realistically, the #1 size table in the United States is a 5 foot by 10 foot table. #1 sheet size is 4 by 8. So realistically, what you really would see is that you would take this gasket tape, and underneath a 5 by 10, you would have gasket for a 4 by 8 area, because you want to work your vacuum only on the sheet size or the work area that you have. In this case, we have condensed the vacuum down into a 2 foot by 2 foot area, because that's the only place that I want my vacuum to be. This next tip is by far the #1 problem that I see shop after shop, is that they don't mill the spoil board properly. And why? Is because they're usually using too small of a tool, too slow, takes way too much time. What can we do to fix that problem?
Well, what I would use is a 2.5 inch spoil board cutter with inserts in it. We ran this tool at about 1,200 inches per minute at 14,000 RPM and took off about a 1/16 of the top layer of the spoil board. Now, this tool is a lifetime tool. You buy it one time, and all you're gonna do after that is replace these tiny little inserts. You can flip them to get more life out of them, but this is a great tool that's gonna mill the spoil board down very quickly.
So I'm gonna go ahead and demonstrate this product right here. So we're gonna turn on the vacuum pump. So we have the vacuum pump zoned into this half of the table. And right here we have some mill marks. So I'm gonna use some ACM, which is very slick. I'm gonna put it right here. And it's not real hard to move it because of all of these marks here. But if I take the same part, same vacuum pump, put it on a milled area, it's significantly different. Now, Greg wanted me to try out this product called Matrix Mat. So I'm gonna put this right here, and I'm gonna move it. Holy snap, Greg. What is this stuff, man?
This is stuff that we call Matrix Mat. This is a thin sacrificial mat that you put on top of your spoil board. What this is it's a grippy foam. So when you put your material on there and you start to cut it out, it is not gonna shift, it's not gonna vibrate, it's really gonna hold it in place, which is gonna improve your cut quality and help you get higher feed rates.
The next tip and trick has everything to do with your cam programming. It's the order of operations, the sequence in which things are performed on your sheet. So I have some show and tell parts here. We have this part here where it has some top milling, and then we have some pockets, and then some chamfer work. This is things that you want to do first because it doesn't break all the way through. Tell me a little bit more about the tooling that you would need to accomplish these processes.
So like you said, you don't want to break through to the spoil board early on in your process. So the order of operations are very important. A tool like a roundover is very smart to do early on in your operation. A tool like a V-groove to maybe put a logo or something like that. A chamfer tool as well. That's something that's not breaking through, it's just beveling an edge. Now, after you use these tools, next in the line of order of operations would be a drill bit. A drill bit breaks through, even though it's not cutting all the way around, it's breaking through, so you want to put it next in your operation.
So we can see that on this part right here where we did the chamfer and then we drilled the holes that we needed, all right? The next order of operations would be to do small entities that do break all the way through. So we would cut these small entities, allowing vacuum to escape, but only through a small area, all right? When you're talking about nesting parts on a 4x8 sheet, you're gonna always wanna cut out all the way through your small parts first. What's a small part? This would be a great example. A part that's about the size of your hand or smaller. Anytime you get to a part this size, you're typically going to need to do something to help your vacuum hold down. Now, in that aspect, I want to talk to you about one of the greatest tricks that I love the most, and that is a 3D ramp. So a 3D ramp demonstrated here is you would take and you would start at the surface, and then it works its way down gradually to depth, creating a ramp. Greg, why is that important?
Well, drill bits are made to plunge, router bits or end mills are made to cut side to side. So doing that ramp or sloping lead-in allows an end mill to be an end mill and cut side to side.
So I'm going to demonstrate here. Now that I've created a ramp, it's going to go around the part, cutting all the way through, and then as I come back, that thickness will get thinner, thinner, thinner to nothing, meaning that the lateral force is getting less and less and less so that your part doesn't break loose at the last second. The next vacuum trick is a little bit more application specific, and I'm going to let Greg take this one away.
So if you're cutting uneven material, which is often hardwoods, or you have to do side profiling, vacuum pods are a game changer. So this vacuum pod specifically has a nice ridge on it, and it's gonna fit into your phenolic table perfectly. It goes through this vacuum zone in here to hold your part. But we also have them where they sit directly on your spoil board. So these are flat, and you can just slap them anywhere you want. So let's do a little demonstration.
So the vacuum is literally coming up through the table and into the pod. And we'll try to, dude, that not going anywhere, man. That's crazy. This is the last tip and trick, and this is very application specific. This is about really small parts that you have to do a lot of. So a repetitive job of, let's say, hundreds of parts that are the same. Now, you can have different variations, and right here we just have some random different pieces. And the way a jig is created is very simple. You start with the shape of what you need to cut out. You come in by a certain amount, and you can put in a little bit of this rolled gasket tape that we got from CNC tooling shop. This allows the vacuum to come up through the grid, through these holes, and then focus only in on the part itself. This allows you to cut faster, cleaner, on much smaller parts that you could ever hold on just a spoil board alone. Using these tips and tricks, your material is not going anywhere. Thank you so much for showing me these tools and the things that we need to increase our vacuum hold down.
Thank you for having me.